Have you ever been running a program and it just stops out of nowhere? Well, today we're diving into the one concept that's designed to prevent exactly that, exception handling. Think of it as the ultimate safety net for your code.
You know that feeling, right? You hit run, everything looks good, and then, bam, it all just grinds to a halt. So what's really going on under the hood when your code hits one of those unexpected roadblocks?
The short answer? It crashes. This is what we call a runtime error, and the event that actually causes it has a name, an exception. It's basically any unexpected event that just completely shatters the normal, happy flow of your program.
Okay, so let's start there. Let's look at exactly when and how code can go wrong. And trust me, it's easier than you think.
So what is an exception, really? Well, the official definition calls it an unusual event that may require special processing. But a better way to think about it is this. It's not just a simple bug. It's anything your code isn't prepared for. Things like trying to divide by zero or maybe reaching for a file that just isn't there. So, how do we stop these little surprises from taking down our entire application? Well, we build a safety net.
And that safety net is called exception handling. The whole idea is actually pretty simple. It's a system for intercepting those runtime errors so we can do something about them. Instead of just letting the program die, we can catch the error and decide what to do next. Maybe we continue on, or maybe we just shut things down gracefully.
And this is absolutely crucial for making our software reliable. Why? Because it lets our programs trap those exceptions, which gives us a chance to maybe fix the problem right then and there. It stops a single, simple error from crashing the whole show. It just makes everything way more robust. I mean, think about the alternative, right? Without a formal system for this, things get messy, fast. As one of our sources points out, error detection code is tedious to write and it clutters the program. You'd end up stuffing your code with if this then that checks everywhere, and your main logic would become almost impossible to read. Okay, so we get the what and the why. Now let's talk about the how. Let's break down the basic flow of how exception handling actually works.
It all boils down to 3 steps. First, you try a piece of code that you know is a little risky. If something goes wrong in there, the code then throws an exception. You can think of this like someone pulling a fire alarm. And finally, you have a special block of code ready to catch that alarm and manage the situation. Try, throw, catch.
All right, so that's the general idea. Now let's get specific and see how this is implemented in a language that tons of people use every day, Java.
So the first thing to know about Java's approach is that it treats all exceptions as objects. Every single one is an object that comes from the throwable class. Now this is a really powerful idea because it means an exception can carry a ton of useful information, like what went wrong, exactly where it happened, all that good stuff.
And this throwable class is kind of like the grandparent. It has 2 main children. On one side, you have error. These are huge system-level problems, like your program running out of memory. Usually, there's not much you can do about these. But on the other side, you have exception, and this is where we spend our time. These are the kinds of errors that a good program can and should be prepared to handle.
Now, here's where Java gets really clever. It splits those exceptions into 2 categories, checked and unchecked. Checked exceptions are for problems that you can totally see coming, like a network connection dropping. In fact, the Java compiler will actually force you to handle these. Unchecked exceptions, on the other hand, are usually for programming mistakes, like trying to access the 10th item in a list that only has 5. The compiler doesn't force you to catch these, because really, you should fix the bug in your code instead. So Java builds on that try-catch idea with one more super useful piece, the finally block. Anything you put inside a finally block is guaranteed to run, no matter what. It runs if everything works, and it runs if something fails. This makes it the absolute perfect place for cleanup code, like closing a file. No matter what happens, you know that file will get closed. So what does this all add up to? What does this mean for the code we're writing every single day? How does this system help us go from total clutter to clean, understandable code?
Well, this is the real beauty of it all. The single biggest advantage is that you can separate your error handling code from your main program logic. Your main code just focuses on getting the job done, the happy path, while all the what-if scenarios are neatly tucked away. It forces you to think about what could go wrong, and it just leads to software that's way more reliable and a heck of a lot easier to read.
So I'll leave you with this thought. Error handling isn't just a defensive move to prevent crashes. It's a design tool.
When you start thinking about what could go wrong right from the beginning, you don't just end up fixing errors, you end up designing better, stronger, more thoughtful software from the ground up. Thanks for watching.